In this lesson, we'll be calculating the value of m given the sigma notation. So remember that we've said that this part here stands for the sum. So they've given you the sum. They said that the sum is equal to 1640 over 27. So what we can go and do is to write the sum. That okay, Sn is given as Sn is equal to 1640 divided by 27. So the sum is given. So what you have to do here is to determine the first three terms. Whenever you are given something like this, you must determine the first three terms, which will help you be able to differentiate or determine whether it's an arithmetic or a geometric series. So remember, we said that for the first term, we are going to plug the number that you see here in this expression. Okay, let me write the sigma so that it can be visible. We're going to say that here we have m, here we have 1 over 2, and multiplied by 3 to the power of k minus 1. And below here, we have k is equal to minus 2. So what we're going to do is we're going to calculate the first three terms. Remember what I've said in the previous video, that in order to calculate the value of the first term, you must plug the number that you see here in this expression. Then for the second term, you're going to increase this by 1. And then for the third term, you're going to increase again by another 1, meaning it's going to increase by 2. I hope you understand it. So let's calculate the first three terms. We're going to say that term number 1, term number 1 is equal to 1 over 2 multiplied by 3 to the power of, we're going to plug negative 2 in the given expression. And then the answer there is given as, let's see, it's 1 over 2 multiplied by 3 to the power of negative 2 minus 1. The answer is 1 over 54. So the answer is given as 1 over 54. So we're going to calculate the second term. I'm going to say that T2 is equal to 1 over 2 multiplied by 3 to the power of, because we have started by substituting negative 2 in the given expression. What are we now going to substitute? If you increase negative 2 by 1, what do you get? You get negative 1. This is going to be negative 1 minus 1. And if you plug that on the calculator again, you should get 1 over 18. That is the second term. And for the third term, we're going to do the same. We're going to say that T3 is equal to 1 over 2 multiplied by 3 to the power of, now what's going to be? If we increase the negative 1 from the second term, if we increase the negative 1 that is here by 1, what is it going to be? It's now going to be 0. I hope you understand this. So here we're going to have 0. And if you do this, this is going to be, let's see, it was negative 1 minus 1. It's going to be 0 minus 1. Sorry. This is going to be 0 minus 1. Because the numbers will go like negative 2, the one that we plugged on the first term, then positive 1, then followed by 0. I hope it is clear to everyone. And if we do this correctly, you will get 1 over 6. So let's clear everything. We know that the term number 1 is given as 1 over 54. Term number 2 is given as 1 over 18, and term number 3 is given as 1 over 6. So I'm going to erase everything here because we have the first three terms, which will help us be able to distinguish what type of a series it is. So we're going to say that term number 1, what is term number 2 divided by term number 1? We're going to prove if it's geometric. If it's not geometric, then we're going to go for arithmetic. T2 is 1 over 18, and we're going to divide 1 over 18 by T1, which is 1 over 54. and if you do that, you will get an answer of 3. And then we're going to do T3 over T2. This is going to be 1 over 6 divided by 1 over 18. Let's see what we get there. 1 over 6 divided by 1 over 18. Well, that gives us 3 as well. So what can you observe here? T2 over T1 is equal to T3 over T2. This means that the series here is geometric. Why? Because it has a constant ratio of 3. So we're going to use the formula for the sum of a geometric series. So we're going to say that Sn is equal to A multiplied by R to the power of, because here, okay, let's just say N. This is the formula. Minus 1 divided by R minus 1. So what is the sum? The sum is given. We said that Sn is equal to 1640 over 27. So wherever we see this, we're going to plug 1640 over 27 on the place of Sn. So let's write it. This is going to be 1640 divided by 27. That is equal to the first term in the series, that is 1 over 54. Multiplied by R is 3. That's the ratio. To the power of n, which stands for the number of terms, minus 1 divided by 3 is the ratio. It's 3 minus 1. So what we're going to do here is we're going to simplify this. 1640 divided by 27 is equal to 1 over 54 multiplied by 3 to the power of n minus 1 divided by 3 minus 1 is 2. So I'm sure you are all comfortable with the idea of cross multiplication. So by cross multiplying, we're going to say that this one times this one and this one times this one. So let's do it and see what we get. We're going to say that 1640 is multiplied by 2. So it's 1640 multiplied by 2 is equal to 127 multiplied by 1 over 54 times 3 to the power of n minus 1. So if we multiply 1640 by 2, we get 3280. So the answer here is 3280. It's equal to, what is 27 multiplied by 1 over 54? That gives us 1 over 2 multiplied by 3 to the power of n minus 1. So what we're going to do here is we are trying to get this thing on its own so that we can be able to apply logarithm. So we're going to divide both sides by 1 over 2, the one which is attached to the 3 to the power of n minus 1. So we divide both sides by 1 over 2 and we divide both sides by 1 over 2. Here the half cancels the half, and this side we have 3280 divided by 1 over 2, and that gives us 6560. So here it's 6560 is equal to 3 to the power of n minus 1. And we are going to take the minus 1 to the left side and it will change its sign. So we'll have 6560 plus 1 is equal to 3 to the power of n. So at the end we have 6561 is equal to 3 to the power of n. And we have come to an interesting part. Here it's 6561 is equal to 3 to the power of n. So remember that the n stands for the number of terms. And we know that we can calculate the number of terms from the sigma notation. So we're going to erase everything here and write this so that we can have enough space to finish. Okay, so we ended at 6561. So it's 6, 5, 6, 1 is equal to 3 to the power of n. So we're going to determine n, which stands for the number of terms. So what are the number of terms in this series? It's given as m. M is equal to top, or just to cut the long story short, let's just use the letter n, the one that we are used to. N is equal to top minus bottom plus 1. So what is the top in this case? The top is given as m. So the top is m and the bottom is minus 2. We're going to plug it inside the bracket and then we say plus 1. So this means that the n in this case is given as m negative times negative 2, that gives us positive 2 plus 1. And at the end we have m plus 3. This means that the number of terms in this case is given as m plus 3. So we're going to plug m plus 3 on the place of n, and then we're going to solve for m. I hope this is clear. So we're going to say that, let's erase here once more for the last time. So remember that we've said that 6561 is equal to 3 to the power of n. And we're going to say that 6561 is equal to 3 to the power of, what is n? N is given as, is it m plus 3? Yes, it's given as m plus 3. So we're going to say that this is m plus 3. Remember what I've said in the previous videos, that this one will become the left side, this one will become the base, and this one will become the number. So we're going to say that the left side is m plus 3. M plus 3 is equal to the logarithm base 3, the number which is 6561. And we're going to say that m plus 3 is equal to, what is the logarithm base 3, the number 6561, that gives us 8. So at the end we have m plus 3 is equal to 8, and we're going to take the 3 to the right side and it will change its sign. Therefore m is equal to 8 minus 5. This means that m is equal to 8 minus 5, 8 minus 3, sorry, this is 8 minus 3, because we've taken the 3 to the positive, to the right side, and it changed its sign. So 8 minus 3, that gives us 5. My brain was running ahead of my hand. So this is how you can calculate the value of m given the sigma notation. At first you must know that what's given here is the sum, because we said in the previous video that this thing here, the sigma, stands for the sum, and they're saying that the sum is equal to 1640. This means the sum is given. Then what you have to do is to determine the first 3 terms. These are the ones which will guide you on what a type of series it is. Then after, you will use the correct formula. If it was an arithmetic, you're going to use the Sn of an arithmetic. But we use an Sn for a geometric because it's a geometric series. We saw that the ratio was constant between consecutive terms. At the end, you determine the number of terms. That is top minus bottom plus 1. I hope you understand everything. Thank you for watching.